This is Mohammed Hijazi. I'm doing the technical test for Wildlife Unity Developer job. I was assigned with three tasks. The first is to create a script cleaner that basically deletes all scripts on the game object and its children. The second task is to create an animation recorder that records any changes applied during gameplay for any game on a given game object. And finally, a physics simulation that will add rigid body and mesh render to any game object added to a list. So starting with a script cleaner. Script cleaner is going to be an editor script because I had to create a menu item. So this script had to be put in an editor folder or else it will not work. Also, the script cleaner had a helper method or sorry, a helper script. This is basically the pop-up message or the confirmation message that will pop up once you select this method. So let's start with the pop-up method. The pop-up method is basically just a message. So if all the scripts were deleted, a message will show up saying all scripts were cleared successfully. If not, then no scripts detected. If the game object and its children did not have any scripts. So back to the script cleaner script, it will inherit from the editor class in Unity, and then we create a menu item with a name of game object, because this string game object will allow us to use this menu item in the hierarchy or when right-clicking a game object. So the method is basically going to call two arrays. One is for the parents and the other is for the children. These will get the scripts from both the parents and the children in the selected game object. And then I add it to a list. These two arrays, I add them to a list. Basically, if these two lists are empty, then we will return false. That means no scripts were detected, and the pop-up message will be no scripts detected. If we have scripts in both the parents or the children, then we will run over then we will iterate all over the script list, and delete immediate all the scripts in the game object and its children, and finally show a pop-up that will say all scripts were cleared successfully. And here it is in action. Right click, automation, clear script. All scripts were cleared successfully. And here it is in the children also, a game object with children. They all have scripts. Automation, clear scripts. All scripts cleared successfully. No scripts on any game object. And this is the warning if there are no scripts in the game object, no scripts detected. So the second task is for the animation recorder. The animation recorder, I made it as a mono behavior in order to attach it to any game object that you want to record. And here's the script. I relied on the game object recorder, which allows us to record the changes applied to any game object and then save it to an animation clip. So first is the helper variables from the save folder location, the clip name, the frame rate of the clip, and all the key bindings. These all can be set in the inspector. And the private variables are the animation clip that we will use in order to save the clip. And then the current clip we will use in order to create a new clip each time you save and record. And then the current record bool will help us start and stop the recording. And this index will be used for the naming of the saved clip, so we don't have overrides. So on enable, we will start by creating a new clip. And this is the method. The new clip is a new clip animation. And then to prevent overriding the clip when it's saved, we basically have to change the index of the clip. So if it's clip 00, then the next saved clip will be clip 01, and so on. And finally, we assign the current clip to this clip. Uh, Here I use the player prefs. Uh, this the player prefs allows me to also prevent the overwrite, because if I don't use player prefs and each time you exit play mode, the index that is used in saving the clip name is going to be reset to 0. So when you are recording a new clip for the same game object in a new play in a new play mode, it will override the old animation clips. This player prefs will prevent any overrides. So in the start method, we will call a new game recorder object, and then this method will help us bind any children to the parent game object, and thus any changes applied to both the parent and the children will be saved. And here, if for some reason the designer did not add any clip name in the inspector, we simply assign the clip name to the game object plus animation. And in the update, we control the inputs. The inputs are four. One is to start recording, the other to stop, and then the one to delete the saved recording. And finally, this just for aesthetics, nothing more. So basically, if the game designer deletes all the um, all the clips in the assets folder, and he wants to reset the index of the clip names, he can use this binding. Or else, if it's basically stopped, for example, at number 20, the next saving will be 21, even though all the clips were deleted in the asset. So the start recording clip is going to return a bool, which says true, and create a new clip. This recorded clip, it means it can record, which will be used in the late update. Late update is used just for smoother recording, and here we take a snapshot based on time delta time using the game recorder game object. The stop recording will stop the recording and then save it to the clip, and then we use the asset database to create the clip and choose the save folder location with the .anim, and then save the asset. And the delete the recording is basically just deleting the saved clip. And finally, on disable, we'll save the index of the clip. So let me show you here. It is in action. This is the test game object, and it has the animation recorder script on it. The bindings, the frame is 15, and I will save it in the basically the assets. Okay. Press I to start. O to stop the recording, and here a new asset was saved. If I press P, it will be deleted. And I'll try again. It is a new save, also a new save, a new save, a new save. And here we can delete. Just for testing the changes. Start recording. Stop. Confirm that everything is working fine. Here you can see the change in the position, the rotation and scale for each one. And just to double check that it's working. I'll press one. There it is. It's changing a little bit as we did in the gameplay mode. So the final task is a physical simulation task. The task was to create an editor window, a new menu item here. It's called Automation Physical Simulator. This will open a new window that has a list. This was a little bit complicated because creating lists in editor windows is not broadly explained in Unity and does not have many documents about it. So in order to solve this problem, I had to use a reorderable list class. This allows me to use reflection on a class that is in the scene in order to create the list in the editor window. Let me explain. Also, the physical simulator had to be put in a editor class, but the helper class should not be in the editor class because it's basically a mono behavior. The this task, the physical simulation task, relies on two important classes. One is the serialized object. Serialized object basically helps Unity take an object and serialize it in an editor and basically adding fields and removing fields. And the reorderable list, we will use it and take the serialized object and create the list with it. So the serialized object in this case will be this new class, mono behavior class, that will only hold a public game object array, object to simulate, and it will be a new game object array. This method we will use it later. So here's what we did. All these statics and the strings. This is a helping text that we will use if this physical simulator mono behavior was not an instant in the scene. Because for this to work, we have to put it in an instant in the scene so it can be reflected in the editor. After defining some window sizes and rectangles, we assign a private bool. We will use it a little bit later. On the serialized object, define it and reorderable list, and then we will have a reference for the class, for this class. And now the menu item is going to be automation, a physical simulator that will open a window with the physical simulator name. Now to initialize this class, on enable we will find the game object and we'll have the physical simulator class, this one, that holds the game object array. And if it exists, we will assign the serialized object to be this one, the mono behavior. And then we initialize a list, the reorderable list, that will have the serialized object. And the property inside the object, which is basically the array, the object to simulate, this one, is this array in order to be used in the list. This is just draggable and has headers and other things for drawing. Next, we handle the drawing, the rectangle of this window, of this list. I'm sorry, and then the elements also. This will handle all the drawings. The object label uses this index. So basically, each time you add a new field to the list, it will start with 00, 01, 02, and so on. So this index allows us to do just this. Finally, we always repaint the inspector window. Now, on GUI, we are doing two things. First, we will check if the serialized object is null. So if this mono behavior is not present in the scene, that's what we're testing. So if it's not present in the scene, we will return a warning message and basically exit from this method, not do anything. Just for testing, let's delete it. And you will have a warning message that you cannot find the physical simulation list game object or component in the hierarchy. And if it's present, then everything will work perfectly. And then now if the object is not null, if it's found, basically keep updating the list, and we will reference the list that we did, and then we apply the modified property. So any changes we do in the list here in the window will also be applied to the instance in the scene. Now, as you can see, we can drag also the game objects that we want to add physics simulation to them. And basically, after that, everything is straightforward. This space I use so we don't have any clutter in the window editor. So basically, each time you add and delete a field in the list, this window will expand. and now begin horizontal just for organizing things. And now here the run simulation button and the stop simulation button. We'll have two methods. And after running these two methods, if we run the simulation, then the simulation is active. This is a label. And if we press the stop simulation, then the simulation is stopped, is deactivated. So with the run simulation method, here there's a trick. You cannot just reference the reorderable list, because the reorderable list is basically this whole list. It's not referencing each field in the list. So in order to solve this, uh, in the physical simulator list, in the helper game object, the mono behavior, I returned the list. I added a public method of game object that returns the list. And now on the run, in the run simulation method, we turn the is active bool to true, which means the simulation is active. And now I iterate through the list that I can get from the mono behavior. So this was the referencing the physical simulation list, and then I got the method that returns the array, and then I basically null check if it doesn't have a component, add it. If it doesn't have a mesh renderer, add it. On the stop simulation is the same thing. Also, I do a null check. If there's no, if there is a rigid body, I delete. If there is a mesh renderer, also I delete. And basically that's it. And here it is in action. So after adding the game objects you want to simulate, run simulation, and as you can see, mesh renderers were added. Cube 1, 0, 1, 4, rigid body mesh renderers were added. And if I stop simulation, then the components were deleted, and here simulation uh, is deactivated. Basically, that's it. Again, thank you for the opportunity, and I will be sending these a little bit later. Have a nice day.